In this lesson, we will solve the equation x squared divided by x plus 5 plus 5x divided by x squared minus 5 equals 6. We'll proceed step by step and highlight the important ideas as we go. First, let's display the equation clearly. We will start by noticing the denominators x plus 5 and x squared minus 5. Because they are in denominators, we must exclude values that make them 0. That means x cannot be negative 5, and x cannot be plus or minus the square root of 5. To remove the fractions, we multiply every term by the common denominator x plus 5 times x squared minus 5. This clears the denominators in one step. After multiplying, we get x squared times quantity x squared minus 5 plus 5x times quantity x plus 5 equals 6 times quantity x plus 5 times x squared minus 5. Now, we expand both sides carefully. On the left, x squared times x squared is x to the fourth, and the middle terms cancel, leaving x to the fourth plus 25x. On the right, we first expand x plus 5 times x squared minus 5, and then multiply the result by 6. Now we set the equation to 0 by moving all terms to the left side. This gives us a single polynomial equation we can attempt to factor. We will factor this quartic as a product of two quadratics. Suppose it equals quantity x squared plus ax plus b times quantity x squared plus cx plus d. Matching coefficients gives four conditions. A plus c equals negative 6. A c plus b plus d equals negative 30. A d plus bc equals 55, and bd equals 150. Because bd is positive 150, we try b and d both negative. For example, b equals negative 5, and d equals negative 30. Then ac must be 5, and a plus c must be negative 6, so it equals negative 1, and c equals negative 5. This yields the factorization x squared minus x minus 5 times x squared minus 5 x minus 30 equals 0. Now, we solve each quadratic factor with the quadratic formula. 4x squared minus x minus 5 equals 0. A equals 1, b equals negative 1, c equals negative 5. X equals 1 plus or minus the square root of 21, all over 2. 4x squared minus 5x minus 30 equals 0. A equals 1, b equals negative 5, c equals negative 30. X equals 5 plus or minus the square root of 145, all over 2. Finally, we confirm the domain restrictions. None of these values are negative 5 or plus or minus the square root of 5, so they are all valid. Therefore, the solutions are x equals 1 plus the square root of 21 over 2, x equals 1 minus the square root of 21 over 2, x equals 5 plus the square root of 145 over 2, and x equals 5 minus the square root of 145 over 2. For a quick numerical sense, these are approximately 2.79, negative 1.79, 8.52, and negative 3.52. This matches our algebraic results and respects the domain restrictions. In summary, we cleared denominators, expanded carefully, collected like terms, factored the quartic into two quadratics, solved each with the quadratic formula, and checked domain restrictions to finalize the solution set. Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time only on MyVerse Maths.